Good morning, sixth graders. Today we are going to be adventuring into our last probability topic, and we're going to be looking at dependent events. So our last lesson was on independent events, so two events that did not count on each other for their probabilities, but now today we're going to be moving into dependent events. So let's start with a little bit of a warm-up. And let's review our independent events. So find the probability of picking the following shapes. Each item is replaced after it is picked. So what is the probability of picking a circle and then a triangle? What is the probability of picking a pink circle and then a yellow square? And what is the probability of picking a blue shape and then a green star? And what's the probability of picking a red shape and a blue shape and then a blue shape? So our probability for picking a circle and then a triangle is 3/50. So we get that by we can get the 3/50 by taking our two probabilities times each other. So the probability of drawing a circle is 2 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2/10. Remember, we can simplify that into 1/5. And a triangle would be 3/10. So 1/5 times 3/10 equals 3/50. What about a pink circle and a yellow square? So we would take 1/10, because there's only one pink circle, times 1/10, because there's only one yellow square. And that gives us that 1/100th. Then we have 3, which is a blue shape and a green star. So there's two blue shapes. So we would take that 1/5 again. And there's one green star, so that's 1/10. So it gives us 1/50. And then number 4, red shape and a blue shape. So there's two red shapes. So that's our 1/5 again, because 2/10 equals 1/5. Times a blue shape. So there's two blue shapes. So that's our 1/5 again. That gives us our 1/25. Which event is the least likely to happen of these 4 events? Which event is the least likely to happen of these 4 events? It'd be number 2, because 1/100th is our smallest probability. So a dependent event. A dependent event is the occurrence of one event that does affect the probability of the second event. So with independent events, it didn't affect them at all, but with dependent events, it does affect them. So to find the probability of two dependent events, you must see how the first event affects the second event. So you're going to still do the same thing. You're going to take the probability of the first event times the probability of the second event. But that probability of the second event will be affected by the first. So we can't find each of these separately. We have to think about what's the probability of this and how will it affect the second event be. So let's look at some dependent events. Make sure you pause the video if you need more time to get this written down. So this will be important to look back on today when you're working on your activity. To tell if an event is independent or dependent. So that's your first step. You have to think about, is this event independent of each other? Do the probabilities affect each other or not? If they affect each other, they are dependent. If they do not affect each other, they're independent. So what is the probability that Zach will get a heads on a coin and roll a number 4 on a number cube? So does flipping a coin and rolling a number cube affect each other? Are they going to be independent or dependent? They're going to be independent because flipping a coin and rolling a dice are two separate events. So they do not affect each other, so that will be an independent probability. So you're going to find the probability of flipping a coin, which is 1/2, getting a heads, and rolling a number 4 is 1/6. So you have the probability of 1/12. Let's look at the second scenario. A student chooses a blue cube from a bag of cubes, then chooses another blue cube without replacing the first. So does that first event affect the second event? Are they independent or are they dependent? They're going to be dependent because that first event, they're not replacing. So they're not replacing that first cube. So there's going to be less items to choose from in the bag. So that's going to change our total outcomes and that's going to change our probability. So let's say that there's 12 cubes in the bag and that there's 3 blue cubes. So the probability of drawing a blue cube the first time is 3/12, which equals 1/4. Then the next time, there's only going to be 2 blue cubes left, and there's only going to be a total of 11 cubes in the bag. So our second probability of drawing a blue cube would be 2/11. So that changes the probability from the first time. So we take 1 times 2 is 2, and 4 times 11 is 44. So we have a probability of 1/22 of drawing 2 blue cubes in a row without replacement. So let's look at a few more. The following counters are picked without being replaced. So we will not put them back in the bag after we draw them out. So the probability of drawing a pink and then a green. So we draw, so there's a probability of 2 out of 9 counters. Then the second one, the green, It's not going to affect how many greens are in the bag, but remember, we no longer have one of those pinks in the bag. So there's no longer 9 counters in the bag. There's now 8 counters in the bag. So we have 3 ace as our probability of drawing a green. So then we multiply and we get 6 over 72. We can simplify that because 3 goes into both 6 and 72. So we get 2 and 24, which equals 1/12. So the probability of drawing a pink counter and then a green counter is 1/12. Now let's look at pink and pink. So we already know that the probability of drawing a pink on our first draw is 2/9. But remember, we aren't replacing that pink counter. So once we've drawn that one out, we only have 1 pink counter left in the bag, and we only have 8 counters left in the bag in all. So we end up with 2 over 72, or 1/36. So the probability of drawing a pink and then a pink is 1/36. What about drawing a yellow and then a yellow? So we're done with that pink one. So the probability of drawing a yellow is 1/9. And once we have that yellow out, what's the probability of drawing another yellow? It's 0. So the probability of drawing a yellow and then a yellow is 0 or impossible because there's only 1 yellow in the bag. So our probability would be 0. So what is the probability of picking a square and then replacing it and picking a circle? So is this one going to be independent or dependent? It's going to be independent because you're replacing the shape. So then what is the probability of picking a square and then picking a circle? So the probability of picking a square is 4 out of a total of 3, 6, 9 tiles times 2 9ths. So we get 8/81 as our probability. What is the probability of picking a square and not replacing it and picking a circle? So is this going to be an independent or a dependent event? It's going to be dependent because we're not replacing it. So the probability of picking a square is 4/9. Then not replacing our square, so we're not replacing this square, so then there's 2 circles out of 8. So we end up with 8/72 or 1/9. Then number 3, what is the probability of picking a blue figure without replacement and then picking a red figure? Is this going to be independent or dependent? It's going to be dependent again because we are not replacing. So we end up with blue first, so that's 3/9 or 1/3, and then red, which is 3, but remember we're not replacing that blue item that we drew. That yellow one will still be there. So we end up with 3 reds out of 8 total squares, or 9/72 over 72, which is 1/8. So now it's time for you to try. What is the probability of picking a green, not replacing it, and then picking a yellow? So we take 3/9 because there's 3 greens out of the 9 counters for our green, but we don't replace it, and we get 1 out of 8 for our yellow. So we end up with 3 over 72, which equals 1/24. Now let's look at number 2. What is the probability of picking a blue, putting it back, and picking a blue again? So this one is independent because we're putting it back. So the probability of picking a blue is 2/9, and it's going to be the same for the second one because we put that first blue back in the bag. So it's 2/9 times 2/9, which is 4/81. And number 3. What is the probability of picking a green circle, not replacing it, and then picking a green circle again? So once again, this is our dependent event because we're not replacing it. So our first probability of picking a green circle is 3/9, but we don't replace that green circle. So the second time we have 2 green circles left out of 8 total circles or counters. So we end up with 6 out of 72, which is equal to 1/12. So really the biggest part today is we have to be careful when reading the questions and figuring out whether the 2 events affect each other or not. And then we're multiplying those 2 probabilities together again. So your closing idea today, I want you to think about how are independent and dependent events alike, and how are they different?